Okay, welcome back, E&G 360. Today we're going to look at listing 1.2 in our textbook by Pong Chu. And in particular, on this one, we're going to do a 2-bit comparator. Okay, we have 4 input bits. We have 2 bits from A1, A0, and 2 bits from B, B1, B0. And when A1, A0 is equal to B1, B0, or A equal to B, we're going to assert the output. Okay, so in terms of our truth table, when A1 is equal to B1 and A0 is equal to B0, we assert. Okay, we don't have that case here. Here, we do have it here. A1 is equal to B1, A0 is equal to B0, we assert. We don't have it on the next few entries, and then down here, A1 is 1, B1 is 1, A0 is 0, B0 is 0, we assert. And then we assert down there. So we only have 1 in 4 particular positions, so that would be 4 minterms. And the expression of our output would just be an SOP expression where they're all primed, and then down here none of them are primed, and then we've got the first 2 primed and then the second 2 primed. Alright, so this is the expression we're going to implement with VHDL. So let's minimize this and let's do a new project. Let's see, we will call this guy chapter 1, let's call this listing 1.2. Alright, listing 1.2. Next, and Spartan 3E, the 500 chip, 320. Okay, everything looks good. VHDL, make sure it's VHDL there. Next, finish. All right. I currently have an empty view over here in the hierarchy. No process is running. Project, new source. All right, we want that to be a VHDL module. What should we call this? Let's call this. Let's just call it EQ2. Huh? How about that? 2-bit comparator. Make sure VHDL module is selected. Then next. Now here you can do your inputs, and we could do this time. I've got an input A, right, which is what? It's an input, yeah. It's a bus, and the most significant bit is 1, least significant bit is 0, because I've got A1 down to A0. And then I've got another input called 2, or actually called B. Where's B? And then it's also an input. It's a bus. Most significant bit is 1 down to 0. And then I have AEQ B, and that's an output, so change that to an output. Now that's not a bus, so turn that off. Okay, that's a single bit quantity, and then that's going to stub out my entity section. So if I do a next, finish, notice what I get here. Alright, I've got EQ2 VHD. Now let's take out all the comments here just for all the sake of understanding the pertinent VHDL. And there you go. We just stubbed out this guy right here. Notice I have my library IEEE. I have my library IEEE standard logic 1164 package. All the data types and operators that are in that package. I have an entity block. Notice it's not case sensitive. You can do upper or lower case. The name of my entity is EQ2. I've got 2 input variables, A and B. They're type input. They're both standard logic vector, and they're 2 bits, A1, A0, B1, B0. And then I've got an output, 1 bit, standard logic. All right, so the entity basically says what goes in, what comes out, input and output. Now the architecture, we actually have to implement this guy. Well, you remember, let's bring that expression back up here that we're going to do. We're going to do this guy right here. AEQ is equal to this SOP expression that consists of 4 product terms. All right, so I think I'm going to create 4 product terms to represent those. So let's kind of make those internal variables, and let's do a signal P0, P1, P2, P3, and those guys would be just standard logic, right, because they're going to be a single bit, right? Now what are those equal to? Well, let's do the first one. Well, actually, let's write the final expression. Let's do that. Final expression, final SOP expression. Final SOP expression. And what's that going to be? Well, that's going to be A equal B is equal to, and what's it going to be? It's just going to be P0 ORed with P1 ORed with P2 ORed with P3. There you go. Now we have to set up what P0, P1, P2, and P3 are. Right, so let's do that. Oh, let's just do P0 is assigned the value of, and what we'll do is we'll do A1 and ANDed with B1, and let's see, that's ANDed with A0. It's go back and look at that expression. B0. What I'm going to do here is I'm going to copy this guy. Okay, and actually I don't want PO. That's a common mistake. I want P0, don't I? P0 here. Alright, P0. Actually, I don't want P0. I want P1 there. Lord, I'm making mistakes. So now I've got these expressions, but if you remember right, let's go back and look at that expression. We had primes on the first term, then on the second term we had primes on the first two, and on the third term we had primes on the second two, and on the last one we didn't have any primes at all. Alright, so let's set that up. We'll leave the last one like that, but on the first one I need to complement those guys. So what I can do is I can say not A1 and not B1 and not A0 and not B0. And then down here on the second one we just want to do the first two, so there's not that guy and not that guy, and on the next term we just wanted to do the last two, so there's not there and there would be not there, and the last one's fine. Now this is kind of a messy thing right here, so what I really would recommend you do is put in parentheses here to kind of make sure you understand the level of precedence. Alright, so we want to do a not on all these guys before we do an and. Okay. Put a not on those guys right there, or let's see, parentheses on that so we understand that the nots. Now actually not has a higher precedence, so we could get away without doing the parentheses, but I'm just putting them in there to kind of show. Let's do them down to here, put a parentheses there. So we do not A1 ANDed with not B1 ANDed with A0 and B0. And then down here we could do the same thing just to kind of, for a readability point of view. But yeah, I actually should try it and take out the parentheses, and I bet it works simply because not has a higher precedence than and. And there you go, and I think we've implemented our expression, right? We're done. Now, this guy right here, we could change our architecture name to SOP architecture, because we're actually using SOP to implement this guy. Okay. So now you've got an entity, which is EQ2. You've got an architecture, which is the implementation of EQ2, and it uses an SOP approach, so we call that SOP. And you can make these names whatever. If we did a POS, we could change that to POS. If we did a NAND gate, we could say a NAND implementation, and etc. All right, so I think I've got everything typed in okay. Let's go save the file. Highlight the file, and then let's go to simulation. Notice I have implementation checked, which gives me all these other processes down here. Let's go to simulation since I don't have a board here with me. And then I highlight my VHDL, I come down to my processes window, and I say behavioral check syntax. And we're good. We just completed a VHDL file. All right, I'm going to stop right here, and then in the next video we'll simulate this and look at some output. Thanks for watching.